Problem 8. Four identical masses of M are kept at the corners of a square of side A. Find the gravitational force exerted on one of the masses by the other masses. Okay, so take one square. This is a square. On the four corners of this square, we are keeping identical masses. Okay, it is m1 and m2, m3 and m4. Then find out the force of attraction on one of this mass from the other. Okay, so every side is given here, that is equal to A. Okay, so first suppose if m3 is applying a force on m1, m2 is also applying a force on m1, m3 is also applying a force on m1, then how how we can write it is like this: m2 applying a force on the m1, that's why it is attracted this direction, and this force is force on 1 by 2, so f12. Like that, force by the m4 on the m1, that is equal to force on 1 by force 4. Then m3 is also applying force on it. Okay, this is the direction of the force of f13. Okay, so then now we have to find out the all these how much forces are acting on them. Okay, there are total 3 forces acting on the m1. Okay, one is this one. Okay, so one is this one. Okay, and another one this one, and another one this one, means like this. It is m1 and there is a one force, and this is another force, and this is another force. This is f14 and it is f13 and it is f12. Okay, so if we are taking this f12 and f13, these two are started from the same point, so that's why the magnitude of those two forces already we are calculated in previous problem also, that is from the parallelogram law of vectors, and the resultant of these two vectors is acting along the diagonal of this square, and in the direction there is one more force, that is equal to what, f13. So means in this direction we have it two forces. Okay, that is the resultant force of f12 f14 is also along the direction of f13. So the total forces are write down here, that is f12. Okay, force on 1 by 2 is equal to g identical masses, so that is m1 is m and m2 is also m, by distance is a square. Okay, that is equal, this is m1, that is equal to m2 is equal to also m, so that's why this is, and the distance between them is how much, a, so it is equal to gm square by a square. Like that, force on 1 by 4, force on 1 by 4, that is equal to also how much, g, masses are same, m into m, by distance is also a square, so it is also gm square by a square. Then what about the force 1 3? Okay, it is equal to, here the distance is different than this distance between m3 and m1, this is the diagonal of square, and that is equal to a root 2. Okay, so if it is a, okay, the length between the square side of a square is a, then the diagonal of the square is a root 2. So then write down here formula, that is g m1 m2, that is also m, it is also same identical masses, so m by distance is nothing but here a root 2 whole square, and that is equal to gm square by, and this is a root 2 square means that is 2 into a square. This is the force on force F13. So these are the forces are acting on this one. Okay, but here the total force on M1 is equal to the resultant force of F12 and F14. Resultant force of F12, F14 are acting along the F13. So total force, that is total force is equal to Fr plus F13. So what is the Fr here? Fr is equal to under the root of force F12 square plus F14 square plus 2 F1 F2 into cos theta. Okay, so plus F13. Okay, this is the Fr. So here it is equal to Fr. It is also in the direction of F13. So that's why these two vectors we are adding, this one. Okay, so from this the angle here F14 and F12, that is equal to 90. So cos 90 is equal to 0. So that's why it is equal to, we can write F12 square plus F13 F14 square. Cos 90, it is equal to 0. So that's why this total term becomes 0, and this is equal to F13. Then write down here what is the F12 and F14. That is F12 is equal to, that is gm square by a square and whole square, plus F14, that is also how much, gm square by a square and whole square. So plus this is F13. F13 is equal to gm square by 2a square. Okay, so then in the root we are taking this gm square is common. So that is in the root, that is gm square by a square, we are taking the common. So then if you are taking that common, gm square and whole square, not only. Okay, so gm square by a square whole square, gm square by a square whole square, the total whole square form we are taking the common, then that is equal to 1 plus 1. So after this taking common, here it is 1, and after taking this common is 1. Okay, then plus it is equal to how much, gm square by 2a square. Okay, so from this root we are taking, this is from the root, outside the root, then this is equal to gm square by a square under the root. Okay, 1 plus 1 is equal to 2, that is root 2, and this is in the root, it is a square, whole square, then the square root of this one is equal to gm square by a square, and the remaining is here plus, okay, that is gm square by 2a square. So from these two terms we can take the gm square by a square is also common. If you are taking that common, here it is equal to root 2 and here it is equal to 1 by 2, and this is the total resultant force.